Welcome to lesson 36. We're going to talk about angles that are greater than 360. So we know that in a Cartesian coordinate system here, that we have four quadrants that are each 90 degrees. And when we measure from X, and we measure to the first vertical y-axis, that's going to be 90 degrees. The next axis, which is an x-axis, that's another 90. 90 plus 90 makes that 180. And then from here to the negative y-axis is going to give us another 90, so that's going to be 270. And then back to the starting point is a full circle, and we know that a full circle is 360 degrees. That's that fourth 90. Well, what happens when we have a degree of measure that is greater than 360? Well, if it's greater than 360 and it's positive, then we started at the positive x-axis and we continued around until we got to that degree of measure. Let's say we had a degree of measure of 400. So we went around one time, that's 360, and then we did another 40 degrees, and that 40 degrees and the 360 degrees gave us a 400 degree angle. Now, whenever we're doing our calculations of sine and cosine, what we would do is we would subtract a 360 and we would get 40, and we would use the degree of 40 for our trigonometric functions. Okay. Now, this is called measuring from the terminal side, or what we call a positive measurement. Now, if we have a negative that is greater than 360, we know when we have a negative, let's say negative 520 degrees, just for the sake of funsies, we know that we are measuring in the opposite or the clockwise direction, and that's called measuring from the initial side. All right, the initial side. This is the terminal side or the positive side, and the initial side is going to be from the negative side. So a negative would be going all the way around 90, 180, 270. This would be 360. Right? So to find out the rest of it, we would have to subtract, or in this case, add 360 to this. So then this would be 60, 100, negative 160 degrees. So we'd have to go another negative 160. So that would be another 90. And then, so that would be 90. And then that would leave 70, negative 70 degrees. So this would be all the way around to the negative 70, which would give us a 10 degree angle right here. So this would be negative 520, which is technically a negative 160 because it's 90 and 70 more. It would give us from the terminal side a 180, 190 degree angle. From the reference point of the x-axis, we would only have a 10 degree angle, and that's what we'd use for our sine, cosine, and tangent calculations. So you can see how the amount of rotation impacts what we're doing and how you need to resolve it to its smallest relative x-axis dimension. Okay, so that's all funsies and well and good. We kind of understand that. That's almost common sense that we want the smallest term or the smallest degree possible to have to deal with because it makes our calculations easier. It just makes our calculations easier. We don't have to deal with, it's like the reason why we reduce fractions. If we don't have to deal with big numbers, then we can do it in our heads. Or if we can't do it in our heads, then we can at least not have to deal with big numbers on the calculator, which is, just a lot easier. we can see better what's going on when we reduce it as much as possible. And if you think of it, that's what we're doing, is we are reducing the degree of measure the same way we reduce a fraction, by subtracting a whole circle from it. We're reducing it down to just what's left over, just the part that is pertinent. All right, that is 36A. There are no practice problems for 36A. It was just an exercise in showing you, first of all, the terminal side is your positive side when you have a positive degree, and the initial side is your negative side. When you measure the opposite direction, you do that because you have a negative degree, but you treat it the same way. Here, we subtract 380 from the positive degree. Here, or 360, here we add 360 to the negative degree, which is going to tell us the remainder so that we can find what we have. And you're going to keep adding 360 to this negative number until you have a value that is less than 360. Then you can start looking at what that actual degree of measure is. Let's say you have a value that is 1375, negative 1,375 degrees. Well, that's obviously multiple rotations. So you would add 360 to this, and you would get negative 1015. Well, you would add another 360 to this to break that down even more. So that'd be 5, this would be 9, this would be 11, so that'd be 5, and that would be negative 655. Then you would do it again. You would add 360 again for the sake of breaking it down even more. That'd be 5, that'd be 9, and then that would be negative 2. Well, now you're finally below 360, so you can start evaluating exactly where that is on the Cartesian coordinate system by measuring from the initial side. And you would say 90, 180, 270. Okay, so 270 is going to be my next quadrant. So I would add 270 to that, and I would have negative 25. Well, then going from here to a negative 25, right? To match that from my x-axis up, that's going to be 65. So you'd have a positive 65 degree angle. And that's what you would use because it's the one that's relative to the x-axis. So keep that in mind whenever you're evaluating these degrees, right? That the negative, especially when you're looking at your polar coordinates, if you have a 6 with a negative 45 degree, then it's going to be measured this direction. Right? If you have a negative 6 with a positive 45 degree, then it's measured this way, 45 degrees, but then the negative is switched over here and you have to adjust your 45 degree to the terminal measurement of whatever that is. All right, so just some things to think about with angles greater than 360. So let's move on to 36B.